So, good day everyone. Welcome to the science class. I am your presenter today, Dan Bixway Gabana of the OB35 BMC student. So today we're going to discuss about the subject of the physical science in the quarter 2, MELP 3, week 1. So today's lesson is all about Brahe's observations and Kepler's laws of planetary motion. So this lesson will teach students what are the observations of Brahe's and the laws of planetary motion of Kepler. So at first, we're going to read the lesson objectives. At the end of the lesson, the students will be able to first define the different laws of planetary motions according to Kepler and Brahe, explain the difference between Kepler and Brahe's observations, identify the different kinds of planetary motions. So first, we are going to discuss who is Tycho Brahe. Tycho Brahe was born on 1546 and died on 1601. He is a Danish astronomer and a nobleman known for his accurate and comprehensive astronomical and planetary observations. So, as we seen in the picture, that is Tycho Brahe, and he was a Danish astronomer, and he is known for his accurate and comprehensive astronomical and planetary observations. So he built an observatory financed by the King of Denmark, King Frederick II, which is shown in the picture. It is known as a naked eye observatory with oversized instruments which we call neural gradient. Since that time, the telescope had not yet been invented. So this is the picture, an example of a neural gradient. So when you say gradient, it is a type of coloring where two or more colors transition to each other based on their hue, saturation, or their brightness. He made detailed observations and records of the planets. He was assisted by the mathematician named Johannes Kepler, which is shown in the picture. So, as we see the picture here, the man here under the picture, which is Johannes Kepler. So the goal is to measure the position of planets with high accuracy. These instruments allows Brahe to calculate and measure the position of the planets with high accuracy. He noted that previous measurements of the planets, as recorded in the text of time, were incorrect. He was able to record the position of the planets with the best possible accuracy for naked eye observations, 10 times more accurate than people had been getting until then. However, Brahe was not able to detect any changes in the positions of the stars over the year, which should occur in the Earth revolves around the Sun. If we had, this should have constituted direct proof of the Earth's motion. So, Galilei observation was explained by Brahe through a model of the solar system that Venus has spaces without making it necessary for Earth to be moving. So as we see in the picture, that is Galileo Galilei. So for the continuation, Brahe's model includes all the planets except Earth orbiting around the Sun. So this model satisfies all the observations because it corresponds to the reality except that is viewed from the point of view of someone on Earth. So the next one we are going to discuss who is Johannes Kepler. So Johannes Kepler, he is a German mathematician and astronomer who used the planet data of Tycho Brahe and developed the three laws of planetary motion. So he was also mistrusted by Brahe because afraid to be outshined. His work on Martian data allowed him to formulate the correct laws of planetary motion, thus eventually achieving a place in the development of astronomy far surpassing of Brahe. Brahe's data was kept by his family from Kepler. Eventually, Kepler retrieved the data after the death of Brahe. So, based on Brahe's data, he was able to realize that the orbits of the planets were ellipses. Thus, three laws of planetary motion was formulated. So the next one, we are going to discuss what are the three laws of planetary motion according to Johannes Kepler. So the first law is the law of the ellipsis. In this law, explains that planets move in an elliptical orbit which with the sun at one focus. And second, the orbits of the planets are elliptical. And the third one, circular and elliptical orbits having the same period and focus. And the last one is that motion is not uniformly circular. So the second law is the law of the equal areas. The radius vector describes an equal area in equal times. The motion is uniform, but in order for an object along with the elliptical orbit to sweep out the area at the uniform rate, the object moves faster when the vector radius is short and slower when the vector radius is long. Equal areas, sun at one focus. The next one, planet move faster when closer to the sun and slower when farther from the sun. And the speed at which any planet moves through the space is constantly changing. So the third law, which is the harmonic law, this is the last law of planetary motion according to Johannes Kepler. The ratio of the squares of the revolutionary periods, which is P, for the two planets is equal to the ratio of the cubes of their mean distances. This law was published in 1619 in his book entitled Harmonicis Mundi, in which the period for a planet to the orbit to the sun increases rapidly with the radius of the orbit. So, as a conclusion, the three laws of planetary motion according to Johannes Kepler, they describe how planets move in elliptical orbits with the sun as a focus. A planet covers the same area of the space in the same amount of the time, no matter where it is in its orbit, and the planet's orbital period is proportional to the size of its orbit or its semi-major axis. So that's all for today. Thank you for listening. I hope you understand something in my lesson. Thank you very much.